f of x is 2 tan x. We're told that x is between negative pi by 2 and pi by 2. And g of x is the inverse function. We want to define the defining rule for that inverse function. So let's do the usual thing. So y is 2 tan x, and interchange x and y. So x would be 2 tan y. So x over 2 equals tan y, and that means that y is the inverse tangent of x over 2. So we can say that g of x is the inverse tangent of x over 2. By using implicit differentiation, show that that inverse function can be written in this form. So tan y is equal to x over 2. And that's just taking the tan of both sides here. Differentiating gives us sec squared y dy dx, I'm differentiating with respect to x, is equal to a half. Therefore, dy dx is equal to 1 over 2 sec squared y. Now, we know that sec squared y is 1 plus tan squared y. So that's going to be 1 over twice 1 plus tan y is x over 2, so tan squared y is x squared over 4, which gives me 1 over 2 plus x squared over 2. And so, if we multiply top and bottom of that by 2, we get 2 over 4 plus x squared, which is of the correct form, with a equal to 2 and b equal to 4. Okay. So we want to show this. Basically, we want to use partial fractions. So 3x squared plus 2x plus 6 over x squared plus 4x minus 3 can be written as ax plus b over x squared plus 4 plus c over x minus 3. Clearer fractions, 3x squared plus 2x plus 6 is ax plus b x minus 3 plus c x squared plus 4. Let's put x equal to 3, and then we get 27 add 6 add 6, which is 39. This will disappear because of the 3 minus 3. 9 plus 4 is 13, 13c, so c equals 3. Coefficients of x squared, on the left we've got 3, on the right we would have a plus c, which tells me a equals 0. And then let's look at the constants. On the left hand side we've got 6. On the right hand side we would have negative 3b from here plus c, which is 3, and that gives me 3 equals negative 3b, and therefore b equals negative 1. Except I made a mistake there, didn't I? C is 3, so the constant there would be 12, and then negative 3b would be negative 6, making b equal to 2. That's better. And the last part is that we want to do that integral. So that just means basically that we're doing the integral of, so the q here, the q over x squared plus 4. So over the x squared plus 4 would be the b. B is 2. So we've got 2 over x squared plus 4. And then we have the integral, and the r would be the c, which is 3. 2 over x squared plus 4. That looks familiar. It's that. And so we know that if we integrate that, we're going to get the inverse tan of x over 2. So this one's tan minus 1 x over 2. This one is 3 log mod x minus 3, and we have an arbitrary constant.